In this video we're going to be showing you how to use tools like this and this to set up the pinion height in your Salisbury or your rover axle. Right, now we're going to do a bit about the pinion heights, and it's really important to know this because in the book it does get a bit confusing and it doesn't really explain it very well. So to explain it in a practical sense for you, I've set up a rover differential here to explain some of the parts and the pieces that we're going to be talking about. But first of all, in the last video I mentioned about this pinion that was all grooved up and worn. Well, took it down to JP, he put a sleeve on it. You can see there's a harder sleeve on there, and he ground it. So we're ready to go because we really need this piece, right? Now, pinions. Can't remember if I mentioned it in the last video, but this is a pinion. The relationship between the top of here, or should we say the top of here and here, is quite important. As I mentioned before, the crown wheel, which this turns on here, these are ground together, and it's kind of critical to get them the right height. If you don't, they could be noisy, you could get a lot of backlash, you could get all sorts of problems. So it's worth taking a little bit of time. Now, let's have a look at the Land Rover book, and maybe this will explain it. See this picture here? It's showing the different, there's the top of the pinion with the height gauge on, but you can see some's low and some's high. So when it's high like this, the shim needs to go under here and lift it up to get to that height, but when it's low it needs a shim taking out. That's basically it. So how do you work it out, and what do they call that? Well, they call that the nominal height. Nominal height, mate, what the hell are you on about? The book mentions this here. Now JP knocked me this up a long time ago. It's quite easy to make. I'll shout you out the dimensions, but it is on this page. 39.5 is for a rationalised axle, 38.10 is for a non-rationalised axle, and 30.93 is for a Salisbury. This one. This is the one we're concerned about, this smaller one, Salisbury. I marked it with an S, just so you don't get mixed up. So the height of this here has to be the same as the height of this Salisbury to the height of that journal there. So this is why I've set this one up here, so we can use this height gauge, because this was a 24 spline, so we want this height here. So how does it work? It's not really voodoo, it's kind of simple really. But this is one of the reasons why we fitted a dummy bearing in this differential to take it in and out and in and out to try and find it. We also made one for this rover axle as well, just to keep trying them and make sure that we've got the right shims. Alright? Now, before we go any further, on this particular axle that we're concerned about, there were 3 shims, and I did a little video trying to explain how to put them together, the original shims, because you can damage them. If I've still got it, I'll insert it here. But if not, when you take the shims out, let's find a typical shim. Here, this will do. This isn't the one for it, but in the casings there's a knockout, like where you put a punch to knock the bearing out. Invariably these little thin shims get damaged. However, if you glue them all together with a piece of a bit of grease or something like that, and arrange all the little dimples in the same place and put them back in so the dimples go where the notches were, the rest of the surface area will be fine for shimming. And this works in our favour because most of the time, if you're rebuilding a differential with the original shims and just changing the bearings, you will find that the pinion height and the backlash and the float will all be back to standard. It's the bearings that wear out. If you've got problems with the differential itself and you have to change it, or you're going to put something like an ATB in like we're doing here, then it's wise to calculate the shimming again. And it is a bit complicated, and you'll see the reason why you need to have a dummy bearing for this pinion here. So what we did was we got a bearing race here. Should be set up better. We've got a bearing race, ground down the outside, and it's just a push fit because this dimension hasn't changed. I just identify them by putting some grinder marks in here, so I know that is an undersized bearing. Now, setting up the pinion. This is, I know I ramble on a bit, but if you don't know, you'll never find out. So, what I've got here is a nice little setup. This is a miniature version of the one that's missing. So this one is a miniature version of this one. This is like 14 inches, but this is smaller. Now, from experience, when I was playing around with this the other day, the height, the magnetic block is not bad, but it could be better. And this is why I reverted back to this block that JP made me. And we've got two tap-ins. We've got one tap-in for the large gauge, and this is a 5mm. I drilled and tapped this one for this gauge. This is nice to use because when you plonk it down like this, you don't move any settings. You can lift it up, take it over to your height block. So what I'm going to do is I'm just going to pause this video here for a minute, and I'm going to set this gauge up because we have to do both sides individually. This is one of the things that threw me years ago, thinking that you had to do one side then measure the other at the same time. No, you don't. And it's always advisable to do your diffs like this when you're doing the pinion, trying to get it horizontal. On the bench here I can turn this round, put a jack stand under it and keep it and turn it so it's horizontal. Now, if you've been wondering, I have the stubs on here so it goes on axle stand, so it's really easy to move. Let me get this set up. Right, I'm doing it on this side so it's easier to see. Now, I've just turned the height gauge on there, the meter. We've got this on top of the pinion and this on the journal race. We are not interested in the numbers that it's showing now. We're interested in a number that's going to be off this height gauge. So I hope you can see this. I'll zoom in a bit. There. So we've got our piece of granite here. Granite, plate glass, anything, as long as it's flat. Don't do it off your bench because your bench could be all warped or whatever. So we are going for here for a 24 spline height here. So we're going to take our gauge, we're going to put it on the side like that, and then we're going to zero it. Can you see? Let's just zoom in a bit more. There. It's showing 0. It's showing 0.5. Wait a minute. There. That is now 0. So now, what we'll do, we'll take it back over here. We'll put it onto here. And with a bit of luck, when we move this around, there, see, it's on 0. Can you see that? I know the LED lights on LED figures aren't very good, but you should be able to work that one out. Now, that's it. Now, if there's a discrepancy according to the numbers on the pinion, you must add or subtract shims. Now, I'm using on this differential here the original shims. So far so good. So we've got 0. What we do next is we measure the other side in exactly the same fashion. We go from this is going to miss this one, but anyway, you see what I mean? We're going to go from that side to that side. What we do is, if there's a discrepancy, we add both numbers together. So let's say for example, this side was 0, this side was 2. We add them together, so it would be 2, then half it, so it would be 1 either side. And that would be the difference, a thousandth of an inch to lift it up and down. Thousandths of an inch is negligible because the shim size is only starting like 3/1000 of an inch. Tricky. But that's basically the way we do it. So I'm just going to shoot off and get some breakfast. But I've already put the dummy bearing in here with the original 3 shims, sorry. I'm going to put this in now with the bearing and our flange and just nip this up so it doesn't move. You see what I mean? So we're going to put that on, put the bearing, but we're not going to put the crush sleeve in. Whoever put that in? We're not going to put that in yet. That's one of the last jobs we need to do. Alright, so I'll get set up for that. I'll go and get fueled up and then we'll come back. Right, I've got the pinion here. We're going to insert it into this axle. We're going to fasten it down without the crush sleeve, just with the flange here. Nothing else, no oil seal, nothing. Now, bear in mind, where is it now? There is a mark here that says -2. Remember, if it's a minus, it needs an extra shim. But are the shims in this, I've got it all set up already, are the shims in this correct? We haven't measured them, we've just put the old ones back in. Now, just out of interest, I found another casing here without a bearing in. And perhaps you can see what I was saying about the knockouts. You see those little notches there? So if you line your damaged shims up, it's getting heavy. If you line your damaged shims up with those holes where they came out, you'll be alright. So let's get this set up with this pinion in, with no crush sleeve in it. Well, what a frustrating time I'm having. I can understand why nobody wants to do these axles. So I've had a hell of a job trying to read this differential. I've got just a little bit of play on there, not too much, but I've had a problem with height gauges. It just seems to baffle me. Like, this one's too big, this one's okay on my block, but the problem is all this malarkey here, it gets in the way and it touches the back of the gauge. It's very difficult to understand. So usually they go through a pin like, well, get it right, like that. Great, you think, great, no problem. But when you try, you have no room to press the button. You put it the other way around, you can't even see it. But you can see you're limited by where you go. And of course, when you press the gauge, you knock the settings off. So, was this the right way to go around it? No, can't get them in either. Resort to the Land Rover book. It's looking at you right in the face. A little thing like this. Now, I didn't have anything so sophisticated as that, but I did have some adjusting brackets for alternators and dynamos, and I found one here. Just put a bend in it like that. Perfect, because now I've got a big slot here that I can move this backwards and forwards. Not a problem. So I've been playing around with the shims in this and getting nowhere. I think I've got myself more confused than ever. But anyway, if I put this pin on here, no, wait a minute, I'll do it on here first. Oh, now I got an inch one of these as well, but it's so fine you can't read it again. So we'll put this on the block. We'll zero it there, put it onto there. Without touching anything, we'll get the highest point there, is 9/1000ths of an inch. So this side is 0.009. So I've lost all my real shimming. I remembered it from the first one. And then all I have to do for the other side is get a 10mm key, back this off, turn it around the other side, nip it up, like that, nip it up like that, go to your height block, it will have moved a little bit because you've been playing around with it. Like that. Going to go around the other side and have a look. Five. So this side is 0.005. That's 14. Divided by 2 is 7. So we want 7/1000th of an inch. Now wait a minute, I've got me confused now. Which way do we want to be? These are nice analog, you know, like gauges to use because the digital flies around, you know, it goes, you can't bloody read all the numbers. But the problem with the nice thing about this is when you're on a curve on the bottom of the bearing, you need to find the very bottom. So what you'll find is you'll put this on the side and it'll go down and then it'll sort of go up again. So wait a minute there. So say for example that's one side, it'll go this way and that's your very bottom. It's hard to do freestanding, but you'll understand it's because it's on a curve. So you've got high spot one side, high spot the other, and the lowest reading is the lowest reading. So let's get onto this and let's see what we can come up with.